Hello everyone, welcome to OdinSchool. Today in this class, we are going to learn about the most used or most widely applicable component inside Tableau, which is calculations. There are multiple calculations that we can do inside Tableau. We are going to see three of them in this session. Before getting into the agenda, let's first see why should someone learn Tableau. Tableau is a data visualization tool which helps you to create visualization from huge raw data. Whenever we have raw data, it becomes really tedious for any human being to consume the hidden patterns and trends inside it. So what is the workaround to understand the data then? The workaround is to synthesize the data into a visual format, a visual representation through which we can understand the data contextually. That is the idea behind all visualization tools. Tableau stands out for several reasons. One being one of the most easiest tools that you can ever learn. The interface is very friendly, where you don't have to learn too much of coding here. All you need to do is drag and drop, and then you can see Tableau doing magic in terms of creating the raw data into visualization. It allows you to create multiple types of charts apart from the regular ones and several other. Given this credit, learning Tableau becomes vital irrespective of your IT choices. Let's get into today's agenda. Today's agenda is all about, okay, before getting into the agenda, let me quickly introduce about OdinSchool as well as about me. OdinSchool is a technology upskilling platform. They help us continuously acquire new skills. Their motto is to stay skilled and stay ahead. I am Gautam Kumar Jayachandran. I have 6+ years of experience as a senior data scientist. I work in several technologies, starting from Excel, SQL, Python, Tableau, machine learning, and analytics. I work with several domains as well. Given this introduction, let's see what is there in the agenda for today. We are going to learn about logical calculations, numerical calculations, and string calculations. Let's see how can we get started with logical calculations, numerical calculations, and string calculations with a lot of examples. We will use data rather than seeing it in theoretical understanding. First thing is logical calculation. Let's open our Tableau desktop. I'll connect to the sample superstore dataset. Once it is connected, we will try to see all the different logical calculations that are there inside Tableau and create different columns in it. There are two types of calculations that can actually happen inside Tableau. One is table calculation, another one is calculated field. What we are seeing now in this session is about calculated fields. We can create new calculations from the existing data to add more insights to the information. All these calculated fields will be an additional column or a new column in the in the given data set. It will act as a separate column altogether since you are using a calculated field. If you are using a table calculation, you don't have to create a column out of it. You can just manipulate the data that is shown in the visualization with several statistical measures. With that said, a calculated field can be created by several ways. The first thing is I can choose this drop down and then I can choose create calculated field, where it will show me a pop-up and it shows all the calculations that Tableau powers us. This is one way of creating. Another way is going to analysis pane and then choose create calculated field. It again shows you the same pop-up. Or I can right click on customer name or any other dimension and measure, choose create calculated field. So we can write calculations in any ways possible, several ways possible. With that said, let's first see how many measures are there in this data set. The number of measures that we have is discount, profit, profit ratio, quantity, and sales. Now, let me show you what is the sales happened in all categories, all subcategories against the number of quantities sold. First, number of quantity, and then I will add number of sales. What is the amount of sales? Now see here, by selling 2,976 products, the sales was $1,67,380. Now there is no information regarding price per product. What if someone wants to know what is the price per product that has been sold under each and every subcategory? Since that particular information is not present, what we can do is create a calculated field. Here I'll say price per product. Here I'll just give the column name here. Then what I'll do is, see here, I'm going to write a logic here. What is the logic? Sales divided by quantity is will give us the price per product information. So I'll say sales divided by quantity. That's it. That is pretty much what I have to do. Just apply, give OK, and then drag and drop it here. As soon as I drag and drop it here, it tells me a wrong information without a doubt, because I've given aggregated it at a normal level. Rather, what I have to do is, I would like to see here in the view what we have is, we have sum of sales and sum of quantity only. So I have to do the same thing here. So sum of quantity divided by, sorry, sum of sales divided by sum of quantity. I'll remove this and drag it one more time. Now we will see what is the quantity, what is the price per product. Okay, let's validate this as well. I'll use my calculator to show you the calculation that we have done as right. Yeah. Let the calculator open. So 2,976 products has been sold for a price of $1,67,380 as the overall sales. Let's see the numbers. There will be minor differences because of the decimal places, but however it will remain the same. Majorly 2976 into 56 will give us 1,66,656. This is without change. If I wanted to see what is the decimal places in this, that will give us the exact value that we are seeing here. So ideally, if since this calculation is not present, or this measure is not present inside Tableau, what we can do is we can create a calculated field like this and then play with it. This is how to get started with calculated field. What I'll do is let's see logical calculations first. Now let me have subcategory and let me have sales. Now what I'll do is I'll go to drop down, choose create calculated field. Let's see what is the first function that we have in logical. So as soon as I choose this arrow mark, it tells me what are the functions that are powered by Tableau. Here you have logical functions. So I can choose logical functions, and we have these many functions that can be put into use. Now let's start with if. So using if, I can show you and I can show you else if, all those things I can show you with if case. Now I'll say, see here, I'll write logical. Okay, let me write if. Here what I'll do is I'll simply type if. As soon as I type if, the machine will ask me what is the condition that I need to write. I'll say if the sum of sales is greater than the average sales. Okay, if the sum of sales that we are seeing here, if it is greater than average sales, then what we can do is we can say, then I will say above average. Okay, I can end this. So whenever I open a if statement, I have to end this. I'll apply. It says the calculation is valid. Tableau is very interactive, wherein if you have any errors in the data set, any errors in the calculation, it will throw the calculation upfront. Let me enable this as T, or let me put this in rows. Everything is above average because the problem is it is calculating 1,67,000 divided by 1 only for each subcategory. So what I have to do is I have to calculate the average sales at a fixed level. If I calculate the average sales at a fixed level, what happens is it gives me, just again, I'm using average. We are using LOD, level of detail expressions here, to generate such value. So I'll say if this should work. I'll say this is also wrong. I can simply keep sum of sales. Let's apply this. Let me remove this. It went somewhere here. Let me put this in the, I'm putting this in the row shelf. It will tell me whether it is above average or below average. Okay, it is both in both the subcategories. This formula is wrong. So what I'm going to do is I'm going to edit this. I'll first write, let's calculate what is the average sales. I'll remove subcategory. I will see what is the average sales. The average sales is 230. Okay, perfect. So what I'm going to do is I'm going to use it directly in the calculation. See here, where is the function? Right click, edit. I'll write it from the beginning. If the sum of sales that we are having is greater than 230, then what we can do is we will say above average. We can do this dynamically also. If the average changes, we can dynamically do this. I'll show you how to do that as well. Then I'll simply say n. So what happens in this case is if there is any sales that is greater than 730, then it will give me those sales as above average and all the other sales as nothing. We have not specified anything else. So all the sales here are greater than 230, hence it gives me above average. See what happens when I say the sales should be minimum $10,000. The sum of sales should be greater than 10,000. In that case, give me above average. In all other cases, I did not specify any condition, so it will be null. See here fasteners are null because the sales value is less than 10,000. I think everything else is also greater than 20,000, so I'll keep 30,000 as sum of sales threshold. If I keep that, there are a couple of subcategories where we have null. Why? Because we have written only one condition. If it gets fulfilled, it will give me an output. Other which ways, for all the other conditions, it will fulfill, it will retrieve null. What if I wanted to add one more condition to it? There are several ways in which we can add one more condition to this. The first one being I can use a else statement to achieve this. I'll simply say before end, I'll simply say else below average and then end this. So what happens in this case is whatever that fulfills this condition, which should be greater than 30,000, then those values should be specified as above average, and whatever that are below this value will be below average because I'm using else statement here. See here, wherever we had null, it became below average. So wherever we had greater than 30,000, they become above average. So we can use two conditions where one condition will be evaluated by if the if condition is not working or if the if condition is not fulfilled, then the else statement work. What if I wanted to write multiple statement? Let me keep this down. Now I'll write else if. Using else if, I'll say check if the sum of sales is greater than 20,000. If it is greater than 20,000, then give me greater than 20k. Here I'm writing one more condition which also will be evaluated. So I'll write first condition here and the second condition. Else if is again one more condition. Else statement works when all the above condition gets returns fail for us, returns false basically. See here, generally if it is above $30,000, it will be given as above average. Other choice, it will see if it is greater than $20,000. If it is greater than $20,000, it will tell greater than 20k, which is what we have here. In all other cases, it will tell us below average, which is fasteners and envelopes and labels, where we have values that are less than 20,000 as well. So this is pretty much how we can actually play with if and elif. We can write as many else if, as many conditions as we want. I'll check else if sum of sales is greater than 10,000 or not. If it is greater than 10,000, I will say greater than 10k. So in this case, envelopes is actually greater than 10k, so envelopes will be representing the envelopes as well as labels will be given as greater than 10k. Only one thing will be below average. Fasteners will be below average because it is not even greater than 10,000, not even greater than 20,000 or 30,000. So we can write as many conditions as we want to achieve a certain output in the formula. Now, one second. Yeah. So what if I wanted to add two conditions that has to be fulfilled? Now let me apply and close this. Let us add one more information to the business. I will add subcat quantities. Okay. Perfect. So we have multiple input in the data. We have subcategories and we are seeing quantities and the sales for all the subcategories that we have here. Now what I would like to do is I would like to see if two or three of my conditions are getting fulfilled. Let me add two first and then I'll show you how to add three conditions and show you how does it work. Now to do it, I'll edit the same if function, but this time however I'm going to write a different condition with multiple if I'm sorry, I'm going to write a different if function with multiple conditions in the same line. So what happens is I wanted to see the categories, the subcategories that are actually greater, that have sold more than 10, more than 1,000 quantities and have achieved more than $1 lakh sales. Now, how do I write it? I'll say if sum of sales is greater than 10,000 1 lakh and I'll use an AND operation here and sum of quantity should be greater than 1,000. Then in that case give me quantity greater than 1,000 and sales 1 lakh. Okay, I'll simply end this. So here what happens is there are two conditions that I wanted the machine to check and evaluate. If only both of my conditions are evaluated to be true, if only both of my conditions are returning me true, only in that case what happens is it will return me true. In all other cases it will return me false. But here what is the alternative for true? It will say quantity greater than 1,000 and sales greater than 1 lakh. Even if quantity is greater than 1 lakh, even if quantity is greater than 1,000 and even if the sales is greater than 1 lakh, it will not give you unless or until it is both the conditions are fulfilled. Let's evaluate this. um, let me see a use case. See here I have my quantity greater than 1,000, but here it did not give me anything because I've written an AND operation. Both my conditions should be fulfilled. See here, even in this case we have quantities that are greater than 1,000, but the problem is the sales is not greater than 1 lakh. So what happens is the machine will always try to evaluate both the conditions. If only both the conditions are fulfilled, then only it will return me an output. Otherwise, it will return me false because we are using an AND operator. See here, quantity greater than 1,000 and sales greater than 1 lakh, which is true here in this case. Now what we can do is, what if I wanted to see only those subcategories that are greater than 1,000 and greater than 1 lakh in sales? I can drag the calculation written into the filter and choose only this selection that we have written. Just give OK. It will tell you the subcategories where we have quantities greater than 1,000 and sales greater than a lakh. So this is how we can take advantage of different calculations that is there in Tableau and play with it. Now let me add this in the row shelf and then add one more dimension to this. Okay, profit. Here I can write as many and conditions as I want. I wanted the profit to be, so here I can write and sum of profit, we write down this, and sum of profit should be greater than Let's see the profit distribution. 10,000. Okay. And apply this, give okay. See here, the same subcategories have earned more than thousand who have sold more than 1,000 quantities have generated sales of more than 1 lakh, where the profit is also greater than 10,000. So what it tells me in the business is I have to target selling 1,000 products minimum in each and every subcategory to generate a sales of more than 1 lakh, wherein I can guarantee a minimum profit of $10,000 in it. A minimum of 10% profit is there if I sell 1,000 quantities at least. So just gives us a business understanding. See here, our profit is greater than 10,000 here, but unfortunately our sales value is not greater than 1 lakh. So if either one of the condition fails also, returns false. That is exactly where AND operation is used. Now let's use the same logic, but instead of AND, let's use an OR operation. What does an OR operation does is, if either one of the condition is fulfilled also, it will return as true. It does not really matter that all three of the conditions should be, pass. That's it. I'm using an OR pipe operator. Look at this. Almost all the subcategories have either one of the logic getting fulfilled. Here, see here, the quantity is less than 1,000 only, but the profit is greater than 10,000. The sales is also greater than 1 lakh. Here, see here, the quantity is not greater than 1,000. The sales is not greater than 1 lakh. Profit is also not greater than 10,000. All three conditions are failing in both these cases. Only in those cases, our operation will return as false. In all the other cases, all operation will return true. If either one of the conditions is fulfilled also, our operation will retrieve as an output. This is the key difference between AND operator and OR operator. We can play with the logical operations a lot, because in real time we will be using a lot of logical operations to achieve certain output. Let us see what is the other logical function that we have. So I'll choose the arrow button here. I'll go to logical. We have seen AND function, else, elif, end, if we have seen so far. Let's see what is a case function. A case function is again as simple as your if conditions only, but it will work only at a column level. You cannot use it at multiple columns. It can work only at one column level. Say for an example, I would like to, what I can use. Okay, I would like to use different measures. Okay, what I'm going to do is I will drag the condition that we have written here, and then I will drag this out all three of. See here, we had three different measures in the view. We have to use three different measures that is present in the data set to show three different values. What if I wanted to show only one measure value here, and basis the user choice, it has to change accordingly. In all those cases and other cases also similar to this, we can use the case function. See here, I'm going to write create a parameter called measures, where I'll have a string as value. I'll create a list out of it. The list will be profit, sales, quantity. Enough, I would say. 1, 2, 3 measures are there. Discount if I want. Okay. So what happens is, we have created a parameter which will have all the measure names. Here I'll say measure case function. I'll start with the case function. Case function, as I said, it will work only at a particular column level. Here I'm going to ask the machine to work the logic on a parameter level only. Only one dimension it can take. So what I'm going to write is, when someone chooses discount in the parameter, then give me the original discount. When someone chooses quantity in the data set, then give me quantity. When someone chooses sales, then give me sales. When someone chooses profit, then give me profit. I'll end the logic. So whenever you are using a if function and a case function, you have to always end it. Okay, so here I can just simply apply this, just give okay. Now it has created a function. I'll drag it in the text. It is showing something, but we do not know what it is. So I'll ask the machine to show the parameter. It is showing the profit now. What if we wanted to show the sales? As soon as you change the measure into sales, it gives you sales. What if I wanted to show quantity? It shows me quantity. Again, for discount, it gives me the discount. So basically, it gives us the value. We can actually create case function, which is again very similar to a if function only. But in case, what happens is it can work only on one particular dimension at a parameter level. That is what a case function does. Let's see the next function. In logical, we have seen and, we have seen case, we have seen else, we have seen else if also, end also we have seen if also. Let's see if null. Okay, let's see what happens with if null. As the name suggests, wherever if you have a null, we can replace that value with some other value. Let me show you this. See here, in the logic that we have written here, there are two nulls because these two conditions are not getting fulfilled in the written conditions that we have. What I'm going to do is I'm going to replace this null value with something. So when you are working with a condition, if the machine is going to retrieve me null, what we can do is we can replace that null with some other value. I'll say poorly performing subcategories, and then that's it. Have to just close it with a parenthesis. See here the logic of if function actually ends here, whereas what I've done is I've supplied the logic of if function as my first expression in the if null function. After a comma, if once I separate it with a comma, the next argument becomes a replacement for all the nulls we have. Let me apply this. See here, as soon as I have applied it, it has actually replaced all those null values with some other information that we ask the machine to do. It says poorly performing subcategories in all three of the null cases. This is what a if null function does. Let's go on to the next function. If null is there, if function. Okay. If function. So here using if function, what we have done is we have written multiple logics and then we have achieved a particular output out of it, right? I've said if sum of sales is greater than 10,000 or something, give me certain things or check for another value or something else. Now I can achieve the same thing with the help of a if IIF function, where you don't have the ability to write multiple conditions. You can write only one condition here. So what I'm going to do is I'm going to say if the sum of sales is greater than 1 lakh or sum of quantity is greater than 1000. Let me close the parenthesis here. See here, first argument it takes is the test argument. It will test whether this is returning me true or not. If it returns true, then we will write, then whatever output that we write in the then statement will be executed, or else we will write else statement. See here, I'll just give a comma. I don't have to write then or else. I'll say greater than good quantity and sales. This is for my true condition. For my false condition, what I'll say, bad number of quantities and sales. I can just close this parenthesis, remove the first calculation that we have written. Now it will return me. It says the calculation is valid because what I've done is inside if function I've written a test statement. This test statement can be only I can write only one test statement here. I cannot write else if and then write another conditions. It works only in if condition. Whereas we are using if. In this case, it lets you to write only one test condition. Inside bracket, we can write as many test conditions as you want, but at a high level, you cannot ask the machine to test for one more condition than the one that you write inside this test condition. Simply apply this and give OK. See here, it simply says bad number of quantities and sales. Here also it says bad number of quantities and sales. Let me show you both quantity and sales. See here, quantity is also not greater than 1000, sales is also not greater than 1 lakh. Both the cases we are failing this. Even though we have used on OR operation, it returns me bad number of quantities and sales because none of the condition is fulfilled. That is the alternative between if and IAF. Whenever you want to evaluate only one condition, you can use this if functions. Let's see the next ones. IsDate function. So isDate function, what it simply does is it will check whether a value that we have supplied is a date or not. Other which ways it will return me if it is a date, it will return me true. Other which ways it will return me false. So I'll say where is our date? Our date is already a date data type. So if I supply this, it will throw an error. See here, I'll say order date. If I supply order date, see here the calculation contains error. It will say isDate is being called with date. Do you mean string? So what happens is isDate can take only string and evaluate whether it is a date or not. Since this is already a date, there is no point of evaluating it. So what I'll do is I'll typecast the data by supplying converting the order date into string. So what happens is this order date will become a string. Now the machine will check if it is a date or not. It will definitely return us true only if I supply date. Let me just drag this. I will check whether these are dates or not. So I'll drag the, see here it becomes boolean, true or false. So I'm going to just drag and drop it in the row shelf. It will tell me true for all the cases because all of them are dates. If it is not a date, it will return me false. That is what a isDate function does. Let's go on to the next one. IsDate is done. Is null. It will evaluate whether the value that we have supplied is a null or not. I'll say is null of tell me if there is any null present in the order date or not. Again, it will be true or false only. See here, it is false. It means that none of them are nulls. Everything else is, everything has values in it. If there is a null, it will tell me true. Again, it is a boolean output only. All these functions are boolean output functions only. The next thing is maximum and minimum. Okay, not operation is there. Okay, R we have seen, then when also we have seen Zn. Okay, let me show you each and everything. Maximum. So I'll simply say maximum sales, apply this. Cool. So I have applied this, but it throws an error. So I'll remove this and go to the function here and drop it here. Now it tells me what is the maximum sales happened in this quarter 1, 22,638. What is the maximum sales we had into quarter 2, 4,164, all those things. The same thing can be used to see what is the minimum sales happened in a particular time period. It will tell me the minimum sales happened is only one in first quarter, second quarter it is one, third quarter is one, fourth quarter it is also one. The next thing that we did not see is a not function. A not function simply returns you the opposite of whatever logic that we are writing to. Say for an example, I'll say if sum of quantity is greater than 1000, or I'll say and sum of sales greater than 1 lakh, then give me good, else bad. What I'm going to do is I'm going to put them inside one parenthesis and then end the logic. Now what happens here is as soon as I write this, it will tell me whether it is good or bad basis the condition. I've used and condition. So what it simply does is it will tell me that this is bad because this has not achieved $1 lakh as sales, and it has, however, it has achieved quantity as 1000. But see what happens when I use a not function. See here, all bads become good and goods become bad. So just the opposite of um, whatever that we write in the logic here. That is what a not condition does. Perfect. That brings us to the end of um, logical functions. Perfect. Let me recap what we have learned in. I think we have missed only one more thing, which is null. Okay, let me show you what happens when I have zn. Let me apply this. See here, there are a couple of nulls in the logic that we have written because we have not written any uh, second condition. We have written only one condition. So in that case, let's see how can it be replaced with a zero. What if in case of in case I wanted to replace all the nulls that I have in the data set to be zeros, what I can actually do? So in that case, what we can simply do is we can use a zn function. A zn function simply replaces all the nulls with zero. You have to just supply zn into what it says it's being called with string. It has to be called with integer. So what I'll do is I'll say if the condition is fulfilled, then give me 10,000. In all the other cases, give me 0. If there are nulls here, it will give me 0 to it. I'll simply apply this. See here, nulls will become 0. That is what a zn function does. But we have to make sure that we supply a number as output, because since zn is going to return us 0 for null, we are going to have an same data output, the data type output, and which was typecasting error will appear. So these are the logical functions that we can actually play with in Tableau. Let's see the next topic. Once logical calculations are done, the next thing is numerical calculations. Yes, there are a lot of numerical calculations that we can actually achieve in Tableau. Let us walk through each and everything. I'll create a new calculated field. Numerical calcs. Perfect. So let's see what are the numerical calculations that are powered by Tableau. I'll choose number. So if you see here, there are several numerical operations that can be used, but let me walk you through the functions that are useful in real time. We are not going to purely work on cos theta, sin theta and all those things, but even if you wanted to perform sin theta, cos theta and all those things, those numerical calculations can also be achieved with the help of what is this? With the help of Tableau. Yeah. Cool. Let's screen this. First is absolute function. What does an absolute function does? Let me manipulate the data a little for this. Let me create what is the difference between what is this profit. Okay, let me show you the profit. There are no profit that is in negative. Oh, that's sad. Okay, so okay, let me drag this and then replace it with subcategories. Yes, look at this. In profit we have losses also, which means there is a loss of loss of $3,400 in a particular subcategory called bookcases. So what happens is absolute function simply returns the real value of a measure. When I say real value, positive value is considered as a real value. So it will always return us only the positive value irrespective of whatever that measure is. So I'll ask the machine to return me absolute of profit. So see here, it has generated that value here in the calculation. I'll simply drag and drop it in the view. See here, we have 41,937 instead of which we have, sorry, it should be sum of profit, my bad, aggregate sum of profit. Look at this, 41,937, 41,937, 18,138, 18,138, 6528, 6528. But instead of minus 3,473, it has given us 3,473. An absolute function simply returns us only the positive value out of the data set. Here if you see, minus 1,189 is converted into 1,189, whereas minus 17,725 is converted into 17,725. Let's see the next function. Cos theta, sin theta, all those things we can you can use. We are not going to see that. Let's see what does a ceiling function does. Now to show you a ceiling function, first I have to do some calculations. Let profit be there. Yes, I think we already had price per quantity calculated, but let me show you this. So sum of sales divided by sum of quantity. Apply this, it gives me without a numerical decimal value. So let me format this to show you the decimals. Two decimals are enough. Perfect. See here, we have 56.24 which is rounded to 56, 62.19 which is rounded to 62, 9.04 rounded to 9, and we have any, see here, 70.88, it should be rounded to 71, 166.77 should also be rounded to 167. But what does the ceiling function does is, so what does a ceiling function does is, irrespective of your decimal places, it will always convert the number to the, it will always round the number to the highest integer. It basically rounds up the value. Okay, let me show you this. I'll use simply ceiling here and then simply apply here. 56.24 got converted into 57. Let me show you the output separately. Let me keep price per product also before this. Okay, that is fine. Here we are seeing price per product. Let me format price per product also to show you. See here, 56.24 got converted into 57 in this case when we had ceiling. Yeah, even though it is lesser than 0.5, the decimal place is lesser than 0.5, it still got converted into the highest integer. That is what a ceiling function does. It simply rounds up the value irrespective of your decimal places. See here, even though we have very minimal decimal place, 0.04, however, the machine will always try to round up it to the next highest integer. That is what a ceiling function does. But a floor function, A floor function simply rounds down the number irrespective of your decimal places. It will always round down the number. Let me apply this. See here, 70.88 is converted into 70. It did not check what is the decimal place. It simply rounds down to the smallest integer. So this is the difference between ceiling and floor function. Both of them are numerical functions. We have seen seal, cos theta, cot theta, degrees, division. You can use division for creating division, but rather you can use a forward slash for creating division. We have exponential function. We can calculate exponential of a particular value. Exponential of sum of sales. Apply here, it gives me infinity because the values are very high. So what if I give exponential of sales? Again, it will be infinity, I believe, because of the values. The values are very big. It is also infinity in this particular case as well. Exponential of profit ratio. This should produce as a value because the values are very less. So yeah, it has produces the value. Sorry, whereas I should have produced numerical calculations. Let me just see here, it has produces a value because the values in profit ratio are lesser. When you create an exponential, it gives you a very minimal value that can be understood. The next thing in this is floor function. We have seen log, we can use maximum and minimum, does the same thing. Pi function does not take any value. I can simply use a pi function which will return me 3.1415 something. Let me remove this, drag and drop it one more time. So here it gives me sum of numerical calculation. It adds the pi value for each and every element and gives you the overall value. So 2936 76 times it might have given 0.3.1415 something pi value, and it is giving you the sum of that pi value here in this case. So that's it there. After that we have power function, round function, sine function, square root and square function. Zn function is also present here. So let me see. Let me show you power function. So I'll say 2 power function. Sorry, I'll use power. I'll say 2 to the power of 2. So it should give me 4. It gives me 4 and it adds the value of occurrences of this power 4 in the data set and then adds it together to give us the value completely. Then we can use a round function. A round function helps you to round the value based on the number of decimals you wanted to have. I'll say round sum of sales instead of price per product. Let me show you sales. Apply this. Remove this and replace this. See here, it is rounding off the values with 1 decimal places in it. What it will be only 1 decimal it will be showing. The other decimals it will be rounding it off. We can actually round the values as many decimals as we want based on the requirement using round function. So I can say give me round it off to 3 decimal places to see if there are numbers. Looks like there are multiple numbers in the sales column. That is what a sound round function does. Square root function or a square function. Square function simply squares a given number. 15 15 is 225, and then it will add all the 225 presents in sub accessories, all the 225 present in all the other subcategories, and gives us the total value of it. Then square root function simply takes a square root of a particular number. Square root of 25, again it will give us 5, and all the instances of 5 will be added together to generate as an output out of it. So this is pretty much how we can actually play with numerical calculations in Tableau. Let's see what's the next one. We have string calculations, very important calculations in Tableau, string calculations. Let me remove this to subcategories. I can add region before. Okay, let's create string calculations. Let's see the number of calculations that we have in string. Huge number of calculations we have in string calculations. If I choose string, it gives me these many calculations that can be used. So the first one is ASCII R character. Both these cases are used only for understanding what is the ASCII style of a particular character. What is the ASCII for A? What is the ASCII for A, B, and all those things. But since it is not a development use case, let's use the next one. Contains function. A contains function simply takes a string and see if a particular value is present in it. A particular element of the string is present in it. Now I would like to remove this and then keep only subcategories. That way we can see the visualization. I'll say contains function where the string is subcategory. Now I would like to see all the subcategory that actually contains IRS. When I say IRS, chairs, okay, it doesn't, it gives me only chairs. What if it has ES in it? I'll apply this, drag and drop it in the row. Accessories as ES, appliances also ES. In art there are no ES. In binders also there is no ES. In bookcases there is ES. In envelopes also there is ES. So wherever, in whichever place the string is present with a substring which is ES, then we will go ahead and say it is present. Other which ways we will say it is not present. Cool. The next thing is starts with function. A starts with function basically again takes the same thing, but it will eventually evaluate whether a string starts with a particular value. I would like to see all the strings that actually starts with A. So what we can do is, rather than keeping it in the calculator view, we can put it directly into view. So it gives me the subcategories that are starting with A. What if I wanted to see ends with? I wanted to see all the categories that are ending with ES. So I'll just simply apply this. It gives me all the subcategories that are ending with ES. Accessories, appliances, bookcases, envelopes, machines, phones, supplies, and tables. And these are the three ones that we use. Let's see the other calculations as well. Okay, find function is also there. What does the find function does? Basically, find function simply tries to identify a position of a substring. So when I say position of a substring, I would like to know what is the place in which we have what is this? Where are the string calculations? Let me put it in the row shelf. I would like to see what is the index position for a particular string. What is the string in subcategory? I would like to search for E in all the subcategories. Wherever it is present, give me that particular information, particular index position. See here in the fourth index position, we have E in accessories. In appliances, it is present at the ninth category, ninth position. In art, there is no E. In binders, that is present in the fifth place, and so on. We can also specify where the machine has to start searching for. I would like the machine to start from the fifth character of the word. So what happens is, if there are any E's after the fifth character, which is yes in this case, it will produce the index position of that particular E. See here, it has given me 10. In the 10th position, we have another E in the subcategory. In appliances, it is already greater than 5. In binders, it is present in the 5th position itself, so it gives us a value. There will be no values that are less than 5. In paper, we have E. Since we have asked the machine to start evaluating this operation only after the 5th character, then it produces us 0 for paper in this case. That is what a find function does. A find nth function. A find nth function tells us the occurrence again, where we have to specify the substring category and what is the substring that we wanted to say. I would like to see the second occurrence of A in each and every subcategories. Maybe I'll say E. If there are two E's in the subcategory name, Then what is the position of that? So in this case it is 10. In this case there is no second occurrences of e, only once it has present, so it will return me 0. See here, only in this case we have two e's, one is present here and the second one is present here. The second one is present at the 10th index. In envelopes also the first e is present in the beginning itself and the second e is present at the fourth character. That is why we have 4 here. In fasteners we have the first e present in 5 and the second e present in 7. Returns us 7 for us. So find nth actually takes the occurrence and identifies what is the index position of it. IsDate function we have already seen. What is a left function? Okay, a left function simply returns a particular number of character from the beginning. So say for an example you have multiple values, you would like to retrieve only certain set of characters from a particular dimension. How can you do it? If you wanted to do it on the left side, if you wanted to do it on the right side, if you wanted to extract or subset a string from the substring from the string in the middle of the data, that all those string operations can be done using string operations. In the left function we can specify subcategories and then I can say how many characters from the left side I want. I wanted the first 4 characters from the substring, from the subcategory string. So ACCE will be given, APPL will be given, ART completely will be given, here BIND will be given. See here, it gives me the first 4 characters. If there are no 4 characters, it will end the operation. The same thing can be used to retrieve the values from the right side also. Give me the last 4 digits. Give me the last 4 digits in each and every subcategory. Can be done with the help of right functions. Here it gives me RIES, NCES. In art there are only 3, so it gives me 3. DERS, ASES, AIRS, IES, OPES. All those 4 characters are retrieved. What if I would like to retrieve from the middle of the data? I would like the machine to start from a particular position. I will say from where you want the subsetting operation to be done. From the 4th character, start the subsetting operation and give me 3 characters from it. Now the 4th character here, 4th character is E. So it will give me E, yes, yes. Because I've asked the machine to give me only 3 characters from the 4th character. In art, there are no 4th character, hence it will return me null. So it has written me null, blank basically. So it gives me from the 4th character 3 characters to it. So we can specify if I wanted to subset a substring from a string, I can subset it from the left side of the string, or else I can subset it from the right side of the string. Also I can subset the data in the middle of the string as well. So 3 different places to subset the data from. That's pretty much what we have to learn in string calculations, I believe. Let's see. Okay, length function is there. That is a very important function. A length function simply counts the number of characters that are there in the string and returns you the value. What is the total number of accessories, characters and accessories? 11. Appliances is a 10-letter word. Art is a 3-letter word. Binders is a 7-letter word. Gives you the number of characters. Then we have lower function. Okay. A lower function simply converts everything into lowercase. See here, it converts everything that is there in the data set into lowercase, whereas an upper function simply converts everything into uppercase. Everything into uppercase. Then we have trim function. What does a trim function does? A trim function simply removes extra spaces if they are present in the left side of the data point. Since there are no extra spaces, white spaces, it gives us the value as it is. What if the data is present in there is an extra space present in the right side of the data? I can use R trim also. Or what if I wanted to remove all the white spaces that are inside the data point, irrespective of left side or right side? I can simply use a trim function, which will remove all the subspaces that are unnecessarily present in the data set. Okay, split function, space function is there, split function is there. Starts with you have seen everything else. Okay, split and space. A split function simply breaks the data into two pieces if it is separated by a delimiter. In subcategory there is no space. Let me add the manufacturer information. Too many manufacturers are there. Generally I have only one city name. I'm just saying for a perfect. We don't have much, but we have only one. I think ship mode has two words. Yes, first class, same day, second class, and all those things. What I'm going to do is, see here, I'm going to write a string calculation. Where is it? Where I would like to split the first class into first separately, class separately, same separately, day separately, second separately, class separately, standard separately, and class separately. How can I do it? I'll say split. In split, it will ask what is the string on which you wanted this operation to perform. I would like this operation to be performed on ship mode. Then it will ask you based on what delimiter you wanted me to split the data. The delimiter here is a space, so I'll create a space. And it asks me what is the token number that you wanted to return. So when I say token number, it will return me either the first value or the second value. It will not give me two columns, it will give me only one column where it can give me first or it can give me class. If I say token number one, it will give me first, same, second, and standard. If I give two, it will give me class, day, class. Let us see both. If I apply this and drag and drop it in the view, see here it has subsetted the data. You know, removed both these words, delimited both these words with the help of a delimiter through which it was actually created. Then it returns me the first token. What if I wanted to return the second token? Second token basically the second element of the splitting operation, which will give me class, day, class. We can use this to perform splitting operation. A space function simply creates empty space based on the number of operations you wanted to have. Say for an example, I would like to create two spaces between ship mode. I would like to join ship mode. Okay, let me show you this with the category. Apply those. See here there are three categories under each ship mode. First class furniture, first class office supplies, first class technology, and all those things. Now first class furniture is not separated by a space. How can we create a space between them? What I'm going to do is I will say space function. I would like the machine to create two spaces before joining it with category. Let me apply this. You will find some space between first class furniture, first class office supplies, first class technology, and all those things. It basically helps you to create extra white spaces in the data set. That is all it basically does. And that brings us to the end of string functions. Using string functions, we can play with all the different text that we have, and then concatenate it, merge it, split it. If you want to have, if you wanted to perform, if you want to generate a subset out of it, you can do that. Several other string related operations can be done with the help of string functions in Tableau. Since this is done, since we have time, I'll walk you through one more type of calculations also. Right click, edit. Okay, let's create a new calculated field. Let's see what is next. We have seen number calculations, we have seen string calculations, date calculations we are going to see tomorrow. We have already seen logical calculations. Aggregate also we will see tomorrow. So the one important other thing is type conversion. What if I wanted to convert a particular data type into another data type? Let us take a use case. Now, let us remove everything. Perfect. We have formatted the numbers. We don't want this to be shown at all, but I didn't like the color. So what we can do is we can actually add the color. Um, how can I color this? Okay, let me keep it in the. I would like to keep everything profit. I'll want to color it light in green maybe. Let's see the other measures. Sales. Sales. Let's change the color. Okay. Next thing is pro quantity. Since discount is a loss, I'm keeping it in red. Perfect. So we have four different colors for four different measures that we have created, and the numbers are showing here. But the problem is discount. I do not know whether it is dollars or thousands or anything. The units is not very clearly visible. This can be simply dollars. This can be simply thousands of discounts. 5,567,000 dollars. Here it is $55,000. But since the units are not specified, and whenever we are comparing with multiple units, look here, we don't want to have these many numbers in this. We need to control the data to a particular extent. So profit has to be in percentage. But if you see here, so okay, we are using profit, not profit ratio. I think discount also should be in percentage. Let's see what is how discount is all distributed, and we will also add profit ratio into it. Discount is also in percentage. It should be showing in percentage, but it is not shown in percentage. So let us keep only discount then. How are we going to control the format in which all these data types should be shown? So what I'm going to do is I'm going to create a calculation, and I'm going to edit the calculation that we already have. I wanted discount only, but how do I want the discount? The discount should be present in percentages. So I'll convert this discount into string, but before that I will round the information. Let's keep only one decimal place to it. String with percentage to this. Then I'll do this for quantity. Quantity has to be a normal number. It should not have any decimal places, but it should be shown in thousands. Since the output data type has to be only one, I'm going to convert everything into string. In sales, the issue is, it's not an issue, I would say. It is let me see if this also works. Okay, here I can say sum of sales. But before inside this, I'll round the sum of sales into one decimal, and then I will convert this into a string. So typecasting is all about changing the data type to the required so that it can be shown. So before only I would like to add a dollar symbol to it. Same happens with profit also, a dollar symbol with a space into it. Then I can say string of sum of, sorry, not sales, round of, round this with one decimal, close the sum operation. This now it says some error. It says because of typecasting, it says cannot mix aggregate and non-aggregate. So if I remove sum, this should work properly for me. Let me remove sum. Yes, it says the val calculation is valid. Let's apply this and see. We have to remove the sum of measure that we have written and replace it with a new calculation where it went measures case function. I can drag it in the view. Since it's already a number, what I'll do is, see here, I will duplicate this for creating, I'll keep this for one for chart, one for representing the values. The problem is, what happens is, when you keep it as a, when you keep these values as a string, you cannot create a chart because it becomes a discrete data. Then you need to, then it becomes really tough for us to create and play with the views as well as charts. So only for displaying the values, I have created a string operation, and then for creating a chart, I'm going to use the same data that we had in the first place. That's it. This will work as a different calculation for me. Measure case function. I'll simply say chart. This I'll use for chart. The numbers I'll use for representing them. I'll drag it here. Since it's a measure, I'll convert it into a measure first. Then I will drag and drop it here. Create a bar chart. Entire view. I'll deselect this. Okay. Now what I'll do is, I'll not enable T. I will drag the values that we created using the function. Okay, showing multiple values. So what I'm going to do is perform this calculation at a aggregated level. Yes. Sum of discount, sum of quantity divided by 1000, and convert this into a string. Sum of quantity, yes. Which will work properly. Like this. It also come here, drag and drop it in the label. Now it will tell me how many values are being present. What is the overall percentage? It shows it in percentage, but I would not like to have it in multiple decimals. So I'm going to keep it into, I'll go to the pane, since it is a font. I would like to control this. Default properties does not have numbers. So we'll have to control it here only. Where can I control it? Perfect. So it is now rounded to decimals without any decimals so that we can see the numbers. So the discount is shown in percentage. If I go to profit, it will be shown in dollars. It says dollar for 4,000. Maybe if I wanted to show it in thousands, I can show it in thousands as well, I believe. Yeah. Okay, that can be done. That formatting can be done. Then I can show the sales. The sales is thousand, 1,67,000 dollars and change, and I can show the quantity, how many quantities have been sold. So whatever that we are seeing here is divided by 1,000. So if I say three in quantity in accessories, it means that we have sold 3,000 products in what, in that particular subcategory. So it is all about playing with the data, typecasting the data, and then changing whatever data type into some other data type as and when required. You don't have to create a lot of different calculations, break your head for changing a particular data type into something else. It can be easily done with the help of typecasting. A string can be converted into a string cannot be converted into a number, but a number can be converted into a string. It can be converted, and in both integers as well as floating data types can be converted into strings, whereas a string cannot be converted into anything else. And we can convert a boolean also into string. And I think we can convert all the data types into string, even the date, the percentage, everything can be converted into a string. Whereas, we cannot convert number into sorry, a string into a number or something else. This is pretty much what we can take away from the typecasting operation through which the data type conversion can happen to generate as a desired output in a desired format. Since we have created this, let me format this to show four different colors. I'm going to choose light color and see what happens. Sales, quantity, discount. We can do multiple formattings also, but in the interest of time, I'm just showing you the high level information through which we can actually do the formatting operations in the Tableau. So here we have seen logical operations, then we have seen string calculations, then also we have seen numerical calculations. We have also understood how to perform typecasting and format the data as and when required. Let me try to add thousands into it. Divided by 1,000. Here sales can be divided by 1,000. Here I'll just divide it by hundreds. Profit also I'll divide by 1,000. Perfect. This makes sense. It says 40,000. Okay, since it is thousands, I have to specify that in the view. Let me add that. So what I'll do is, since it is quantity, I'll leave it as it is. Discount will be in percentage. Sales will be in K. Simply apply this. It tells me $42,000 profit, $18,000 profit in appliances, $7,000 profit in art. There is a loss of $3,000 in bookcases and all those things. I can also see what is the sales happened. $167,000 sales happened in accessories, $108,000 sales in appliances. It looks like the number of sales happened was very less in fasteners, where the sales is only $3,000, and all those other information related to it. Quantity will not have anything, but it will tell me 100 products were sold in accessories, 900 products were sold. Okay, since it is not 100 or something, let us format this much better also. I'll say it will tell us more information. Okay, I have not formatted this properly. I will add a space into it. So 100 quantities were sold in accessories, 1700 quantities were sold in appliances, 200 quantities have been sold in copiers, 900 in envelopes, 900 in fasteners. So it gets us the understanding of how many quantities have been sold, through which what is the sales amount that we have generated, through which what is the profit that we have generated, or on top of the overall business. What if I wanted to know what is the discount in bookcases, why bookcases is not performing? Might be discount is less, so I'll go to discount and see here the bookcase percentages, the amount of discount given is less than it is in decimal places only. Since we have rounded the number, it is not seen. So what we can do is we can edit this and change the discount. If here we have given it in 0 decimals, so I'll round it into 2 decimal places. Apply, just give OK. It tells me in bookcases only 5% discount has been given. That is why it has performed really poor. Whereas in binders, it has performed really well. The discount is very high. So let's see what is the profit in binders. The profit in binders is very nice, $30,000 by selling how many quantities? By selling 60-100. Basically that is the most number of products that has been sold in that particular subcategory only, because that particular subcategory has huge amount of discount in it. So I can understand discount is driving my business a lot. So what we can do is, as a business, we can start giving more discounts to the user so that the business can happen. This business can grow rapidly. These are the different types of understanding that we can take away from the calculations. With that said, I think we have covered all the topics for today. Let me quickly recap what we have learned in today's class. In today's class, we have learned about logical calculations, numerical calculations, string calculations, and also we have learned about typecasting. Using logical calculations, we can write conditions and ask the machine to evaluate it. If it returns true, we will ask the machine to perform a different task. If it returns false, then we can also ask the machine to do another task. Basically, writing conditions to ask the machine to behave in a certain way. Multiple conditions can also be written. We have seen if function, IAF function, then elif, else if, and or not. All these things are conditional logical operations only. Talking about numerical calculations, any numbers, when I wanted to manipulate any number that is present in my data set, I can use numerical calculations like square root, square, cos theta, tan theta, cot theta, ceiling function, floor function, natural logarithmic to the base of 10. All those things, numerical calculations can be done with the help of numerical calculations. Then talking about string calculations, if I wanted to identify the position of a substring in a string, if I wanted to perform a replace operation, if I wanted to remove extra spaces that are present, if I wanted to perform subsetting operation in the left side or in the right side or in the middle, I can do all those operations with the help of string functions. Using typecasting, we can convert the data type of a particular dimension or a measure to something else based on its nature. One thing that we need to keep in mind is numbers and other data types can be converted into strings, but strings cannot be converted into other data types. That is the concept of typecasting. With that said, let's wrap up for the day. Please don't forget to like, share, and subscribe to OdinSchool. Thank you so much for joining this class. We'll catch up in the next one.